Greetings, everyone, and welcome to the Pan Future Society podcast. This is a podcast of science and futurism and societal issues and philosophies, ideas, podcast thing for people who don't know maybe that they should be listening to a science, futurism, societal issues, philosophy type podcast. As always, I am your host, Sean, and today, not as always, but uniquely today, is Friday, November 18th, 2016. Often I do the shows on Saturdays, but sometimes the schedule is what it is, and I am doing it Friday night this week. So if you're looking for a TV show to entertain your eyeballs and ear spheres or whatever with, I suggest you check out Humans if you have not. I believe it is a BBC production. I've got it on the Amazon Prime thingy. It's a show about a near-future society where they have very realistic humanoid android robots to assist people and do other things. And it's an interesting, I'm only a few episodes in. I guess they've got a couple of seasons under their belt now. And it's an interesting examination of our human interactions with these machines, which are very nearly human. It covers everything. There are a number of different sort of groups of people in the show. And it covers everything from people who hate them or dislike them or fear them to people who love them as their children, to people who think that these robots should have rights in the same way that we do. So if you're looking for some new entertainment, Humans, check that out. And now on to your news of the moment. Your first news item this week comes from the University of Illinois and lead research professor Stephen Long, and also the University of Lancaster. They have altered the genetics of plants to increase crop yield by 15%. By improving the way the plants photosynthesize. So plants, when they are in the sun, when they get too much sun, they release more energy as heat to protect themselves from getting scorched or whatever damage the sun might do to these plants. So by altering these genetics, they were able to speed up the rate at which the plants switch on and off this protection. It can take, for some plants, apparently up to an hour or so for them to adjust to bright sunlight, then into a more cloudy day and back to bright sun again. And they lose a lot of efficiency taking this long to make that change into their protection system. By changing the genes responsible for this heat loss switch, they were able to speed up the rate at which the plants turned this adaptation on and off, and their experimental crop grew 15% larger than normal. So it was able to use quite a bit more sunlight to grow itself. The United Nations Food and Agriculture Organization predicts that by 2050, the world will need to grow 70% more food than it does now to feed itself, along with the expected increases in population. So also, in addition to just being able to feed people, if we don't increase food production, the food that we have is also going to cost a lot more. So anything we can do to help that along, including doing a little genetic modification, let's go for it. All right. Now, it came from outer space. In the space news this week, the Sputnik Planitia, the heart-shaped feature on Pluto, may be a slushy underground ocean. Data keeps being analyzed from NASA's New Horizons spacecraft, and this region appears to be kind of just a hole, but it has more mass than you would expect for a hole. One explanation for that mass would be if it has water or some kind of liquid like that, as liquid water is more dense than ice. Pluto and its moon Charon are tidally locked with each other. That is, the same face shows to the other object all the time, the same as our own moon always shows its same face to us here on the surface. And one way that the heart-shaped Sputnik Planitia could have ended up pointing at Charon is if a large object like a comet smacked into Pluto, and then gravitational interaction gradually rolled Pluto over to point this particular feature at Charon. This explains the extra mass. The extra mass would have gotten pulled toward Charon, and it's kind of akin to like if you took a basketball and slapped a hunk of clay on one side. You would have unbalanced the center of mass, and it would just roll over. And in this case, because of the gravity, it points at its moon, this heart-shaped object. And so it's entirely possible that we still have a slushy liquid ocean, beneath the surface of Pluto there. So very fascinating, and also exciting that data from the New Horizons spacecraft is still being analyzed, still being worked on, and still showing us some new things about Pluto and some of our deeper space solar system objects. And that is your news of the moment. All right, I'm going to do something a little bit different for this week's main segment. Normally, I'd try to do some more in-depth research on a particular topic, go to some lengths and depths to discuss something about technology or science or civilization. This week I don't have a particular event to talk about. I struggled to come up with a title for this show, and I eventually just settled on Essay on the Universe #1. So you can consider this a spoken essay on some sort of topic that wanders through my brain, such as these kinds of topics do from time to time. Now, also, for this particular kind of segment for this show, I might suggest that you kind of sit back, relax, close your eyes, let your mind wander, let your imagination expand, and consider these things. However, if things that distract you or blow your mind also take your attention away from other things and make your mind wander, you may not want to listen to this show while you are driving or operating heavy machinery. So, with that disclaimer out of the way, we will get on with the rest of the show. Oh, well, one more disclaimer. This section also has a lot of numbers, and that's kind of the mind-boggling part of it. So I think what I'll actually do is I will post the full text on the website for this, so you can also continue to digest these numbers later at your own pace. So It's not math exactly, but lots of big numbers ahead. Quarks and electrons are the smallest known things. They may be made of things even smaller, like quantum strings, but we don't know yet for sure. Some experimental data shows quarks to have, at the smallest, a radius of 0.43 times 10 to the negative 16th centimeters. That's 2,000 times smaller than a proton, which is itself 40 times smaller than the radius of a DNA double helix, which is itself a million times smaller than a grain of sand. Within the human body, there are about 37 trillion cells. Almost every one of those cells contains the DNA blueprint to make more humans. I am one of over 7 billion humans, and one of many billions of living things on the Earth. All of those living things exist on a tiny fraction of the surface of the Earth or in its oceans, which has a diameter of over 12,000 kilometers, a surface area over 500 million square kilometers, and a volume of 1.08 times 10 to the 12th cubic kilometers. Earth is about 150 million kilometers from the Sun, one of 8 planets, many dwarf planets, and countless asteroids and comets. The Sun's diameter is 109 times that of Earth, and 1.3 million Earths would fit inside the Sun. Some of the largest stars we know of would extend out to the orbit of Jupiter, 778.5 million kilometers from the Sun. A star like that exploded to make all of us. The Oort cloud, a suspected collection of mostly comets and other icy objects, is a loosely bound last stop from our own solar system. The very limits of our Sun's gravitational influence is so far away it could take light from our Sun 3 years to reach it. A light year is a measure of distance. 1 light year is 9.46 trillion kilometers. Our Milky Way galaxy is 100 to 180 light years across. There are between 100 and 400 billion stars in our galaxy. The Sagittarius dwarf spheroidal galaxy, a satellite galaxy to our own Milky Way, is 70,000 light years away. Our nearest large galaxy neighbor, Andromeda, is 2.5 million light years away. It is about 220 light years across and contains perhaps as many as 1 trillion stars. There are perhaps 500 billion galaxies in the known universe, each of them containing billions to trillions of stars. The more we look, the more we find planets around other suns. There may be billions, hundreds of billions of planets in each galaxy. The visible universe is estimated to be 93 billion light years in diameter. Even if life is rare, with such large numbers there could be thousands, tens of thousands of planets in each galaxy with life. And if there is life, there is a chance for intelligence. If there is intelligence, there is a chance for curiosity and exploration. If there is curiosity, there is a chance for understanding. 500 billion galaxies, even with one intelligent species in each, is a lot of life looking out on the universe, trying to make sense of it all. Somewhere in the Andromeda galaxy right now, Grubnia Plogrubenhut is recording her Lakritcast about the latest in planet Wibnick's technology for her listeners. But that's not all. It's actually possible that there are an infinite number of universes, an endless list of possibilities made manifest, where everything that could happen does. In some universe somewhere, I am President of the United States right now. In another, I died when I was 4 years old. We don't know if there are other universes right now, but at least on paper, the math can work out. And yet, all of that, all of those billions and trillions, from tiny quarks to massive galaxies and everything in between, account for only 4% of the stuff we can see in the universe. 96% of the universe is stuff we can't see, can't interact with. Dark energy and dark matter are hypothesized explanations for observations made about the universe that don't match up with what the math tells us. The way gravity works, the speed of stars orbiting their galactic centers, and the speed at which the universe is expanding are examples of observations that didn't work out with the math we had when we thought that we could see everything that there was to see. For the math to work out, 96% of the universe is stuff we can't yet detect, let alone understand. Maybe these hypotheses will be proved wrong. Since these gravity problems were first observed in the 1960s by Vera Rubin, we haven't figured out a way to test this. A newer hypothesis suggests that we don't have gravity quite right, that it's an emergent phenomena, not a fundamental force of nature, and a new theory of gravity dispels the need for dark matter. That is a topic for another day, but either way, there is very, very little stuff out there in all that vastness, despite the massive size of stars, the massive number of stars and galaxies. It's still a lot of empty space out there. And matter isn't really solid either. Molecules are mostly empty space held together by the strong nuclear force and electromagnetism. And all of these atoms, all of those cells, all of those people and planets and stars by the billions and trillions, a whole lot of something made of nothing floating through a whole lot more nothing. But wait, there's more. It is possible that all of this is a computer simulation. It's a suggestion that cropped up again a few months ago, but it originates, I think, in 2003. Oxford philosopher Nick Bostrom made the argument that perhaps a very advanced civilization could run simulations of their ancestors with enormous computing power. As silly as it sounds, it can't be dismissed out of hand, although it lies as a question in the realm of something that may be impossible to test, like knowing if there are other universes from within the only one that we know. How can we find out if we are a program from within the program? There are actually ways in which observations we make might provide evidence, primarily in program shortcuts that clearly violate our understanding of physics. Frankly, this crazy idea actually seems more testable than string theory right now. Ultimately, though, it doesn't change the fact that the world is what it is, and we should continue living our lives. One universe of many? Only universe? Computer program? One of the many sentient life forms? Or solitary stowaways on the only lifeboat in all the universes? We owe it to ourselves and all future generations to be better, learn, explore, survive, thrive, and share with all. You and I and all of us are here now only for a short time, And we've evolved the curiosity to wonder, the intellect to understand, the will to find significance in our own insignificance, and the heart to love our lives, our planet, and our fellow travelers in the universe. All right, that is the episode for this week. I hope you enjoyed the essay type thing this week as a change of pace over the usual stuff that I do here. Thank you as always for tuning in. Thanks for getting in touch with me on Facebook or Twitter. If you want to come to the website, it is panfuture.org. If you would like to help out the show, there's a donate link there, or just drop me an email, Sean@panfuture.org. That's SEAN. If you have some time, it would also be great if you write some reviews on your podcast digestion source of choice, whether it's iTunes or Stitcher or YouTube or wherever you happen to be finding the show. I would also greatly appreciate that. And that's all I've got for this week. I will talk to you again in the future.